Welcome to the second part of lesson 4.2. We're going to talk about adding and subtracting rational functions when the denominator is not common. And we're going to start with these two fraction examples similar to things that you did in elementary school. So here's what we do when the denominator is not common. You're going to start by simplifying the denominator. In this case, with normal fractions, that means factor trees. So we're going to change this 15 to 3 times 5. And change that 10 to 2 times 5. Now, to find a common denominator, we're going to multiply by what it's missing. Now, here's what I mean by that. So if I look at this 3 times 5, and I compare it to the 2 times 5, and then I think, what is it missing? Well, it's missing a 2. And then I can do the same thing on the right side. This is a 2 times 5, and if I look over here at this one, what is it missing? It's missing a 3. And now both of these are 2 times 3 times 5. 2 times 3 times 5. So they're going to be common denominators now. They're going to be the same number because they're all the same numbers multiplied. But here's the thing. Fractions are kind of like equations. Anytime you multiply or do anything to the bottom, you have to do the same thing to the top in order to keep it balanced, keep it equal. So I'm going to times this by 3, so I times by 3 on top and bottom, and times this by 2, so I times by 2 on top and bottom. So this is going to be 4 times 2 is 8 over 2 times 3 times 5, which is 30, plus 3 times 3 is 9 over 2 times 5 times 3, 30. There's my common denominator. And now that my denominator is common, I add my numerators to get that. There we go. So let's try this second fraction example. Once again, we need to get a common denominator. So we're going to factor tree and then multiply by what's missing. But in this case, the 7 and the 5, they're as simple as they're going to get. They don't break down anymore. So we get to immediately start at this step, where we multiply by what's missing. So this 5 is missing a 7, and this 7 is missing a 5. And now they're identical. But once again, if I do something to the bottom, I've got to do the same thing to the top to get them to be balanced. So this is going to be 10 over 35 plus 1 times 7 is 7 over 35. There's my common denominator. So I combine my numerators to get 1735. And there's my answer. So now let's apply that to rational expressions. Let's try example number 3. So I'm going to start by factoring or simplifying these denominators. So this 2 is 2 times 2, and that 10 is 2 times 5. So let's rewrite this. 7a over 2 times 2 times b plus 4c squared over 10 is 2 times 5. And now I'm going to multiply by what they're missing. So if I look at this one and compare it to that one, it looks like this one is missing a 5. And then if I do the same thing, look at this one and compare it to that one, looks like this one needs another 2 and a b. And now they both got 2 2s, a 5, and a b. So they're going to be common. They're going to be the same thing. But when I multiply to the bottom, I need to also multiply to the top to keep it balanced. So now I'm going to have 5 times 7a, which is going to be 35a, all over 5 times 2 times 2 times b. So that's going to be, let's see, 1020b, I believe. Plus 4 times 2 is 8bc squared all over, also 20b. So there's our common denominator. So now we can add our numerators. And now we need to do that extra step of checking to see if it will simplify, just like we did in the last video. So I need to see, does this top have a GCF that I can take out? Well, it doesn't look like there's anything common between 35 and 8. So this doesn't simplify anymore, which means that's my answer, because nothing cancels on top and bottom. Okay, let's try example number 4. So once again, we need to check for any common denominators. This one does not have a common denominator, so we need to make one. So x doesn't really break down to anything. 3x squared plus 20, I can't really break that one down to anything. There's no GCF in that I can take out. So that means I just get to multiply by what's missing. So it looks like this side is missing an x, and it looks like this side is missing a 3x squared plus 20. And now the denominators are common. But remember, what I multiply to one side, I have to multiply to the other side. So I've got, I'm going to put that 20 first, that just helps me. That over that plus x times 200x all over my denominator. And you'll see at this point, my denominators are common. So since I have a common denominator, I can add my numerators. So there we go. I've added my numerators together. Leave my common denominator. And now I need to simplify my numerator. Now remember, order of operations from junior high. Multiply comes before add. So I need to multiply these before I can add them together. So that's what I'm going to do. 20 times 3x squared is 60x squared. 20 times 20 is 400. Plus x times 200x is 200x squared. All over my denominator. And now that I've multiplied everything, now I can add, meaning combine our like terms. So 60 plus 200, so 260x squared is my only like term. And now I'm on that last step of double checking to see if anything will cancel. So I'm going to check for a GCF on the top, which is going to be 20. So divide both of these by 20, and I'm left with 13x squared plus 20 all over my denominator. So now I check, can anything on top and bottom cancel? Doesn't look like it for this time. So there we go. That's our answer. Okay, let's try another one. Let's try example number 5. I want you to start this one on your own. So you're going to first work on that common denominator. So we're going to factor this first one and look for a GCF on the second one and then multiply by what the denominators are missing. So try and find that common denominator first and come back and check to see if you did it right. Welcome back. Let's see how you did. This one on the left should have factored as x plus 5, x minus 3. And this one over here has a GCF of 5, so I take that out. And then now I'm looking for a common denominator. So if I looked at this one and compared it to that one, it was missing a 5. So I added that 5 in on top and bottom to keep it balanced. And then if I looked at that one, compared it to that one, it was missing an x plus 5. So I added that in on top and bottom. And now I've got this common denominator. Now, I will tell you, a lot of students on tests at this point go, oh, hey, 5 on top, 5 on bottom cancels, x plus 5 on top, x plus 5 on bottom cancels, and then they try to do stuff from there. That's just working backwards, though. I mean, we added that 5 and that x plus 5 specifically so we could have a common denominator. So let's not take them away. That's what we just did. So now that we have a common denominator, I am going to combine my numerators all over that common denominator. And now I want you to practice doing this next part on your own. Remember that we need to multiply first, which in this case means distribute, and then combine our like terms and check to see if it will simplify. So I will pause the video, try that next part out on your own, and then come back and see how you did. Welcome back. This is what you should have ended up with. So I multiplied those in to get this numerator, combined my like terms to get that numerator, and then saw they have a GCF of 3, so I took that out, and then there's nothing on top and bottom that will cancel, so that should be my final answer. Okay, let's do, I think that's all I'm going to end with today. If you have a problem that looks like number 7, I would start by taking it one step at a time, where look at it as 2 different fractions and simplify them separately first. And then when you've simplified those using the exact process we have up above, put them back in, and then you'll do flip and multiply like we did in 4.1. So if you want to try that out on your own, you're welcome to, but example number 5 is the kind of problem I wanted to focus on. So you should be able to get started on your in-class practice for sticker as well as your Canvas homework.